All right. Good morning, everyone. I always forget to introduce myself. I'm not going to forget to do that now. I am Chrissy Rismeyer. I'm the Director of Digital Library Development at the UC Santa Barbara Library. I also serve as UCSB's project owner for Project Surfliner. And I want to take a moment to thank you all for being here today. And that includes if you're watching this at a later date. We really appreciate you being here. So before we officially get started, I did want to just note that this meeting is recorded. So we will ask you to please keep yourself muted unless you are speaking to help keep the audio recording clear. If any questions come up when we're presenting, please feel free to drop them in the chat. We will hold off until the end just so we can keep things moving efficiently. But let's go ahead and get started. So welcome. Actually, Michael, I'm going to ask you, do you mind unmuting yourself and just introducing yourself before we dive in?
Sure. I'm Michael Stewart. I'm the Assistant Director for Technology and Digital Experience at UC San Diego. And like Christy, I am a project owner for Surfliner and help represent the development and infrastructure teams that are doing this important work.
So we did decide, we were talking about this as a team and have decided that we want to approach this month's update a little bit different than the ones we've done recently. Really in our past updates, we've really been focused on what have we accomplished during our last work cycle, which normally is around 9 to 10 weeks. And this time, I feel like where we really want to do is to try to help you answer this question. Are we there yet? And the answer to that is not quite yet, but we are really close. So we are going to spend some time touching on what work we did accomplish in the last work cycle. Our goals for today is really for you to walk away with a pretty good sense of where we're at, what work remains, and what we're working on in the work cycle that started yesterday. So our agenda, we're going to start out just by doing a really quick recap of our last work cycle, touching on the high-level themes that were really guiding our goals. We're going to get updates about where we are with the discovery platform work, also on our digital object management platform. We do want to touch a bit on, I think, a little bit of a curveball that was thrown to the team, which was looking at both infrastructure resilience and also vendor independence. Have each campus, UCSB and UCSD, provide an update on their respective data migration efforts, and then really briefly touch on our goals for the current work cycle, and then hopefully have lots of time for questions at the end. So I'm going to turn it over to Michael to just recap the last 10 or so weeks.
Sure. So I think the thing to take away from here is our last work cycle was really running June through a little bit of September, and that was really broken up into three-week sprints with some buffer there, period. And we're going to be touching now on some of the goals and themes going forward. It's also worth noting that those work cycles are now running back to back, whereas previously we had a fair amount of space in between those. So that buffer period, shortly after that, we have started the next work cycle, which we're currently in now. Work cycle 4. And so our work cycle 3 themes, we really wanted to, and we did focus on completing the next version of our connected system, which is really sort of trying to marry the discovery and content management platforms into one functional product. We were making a lot of progress on completing our content management, our Comet MVP features. And we're also completing environment redesigns to sort of make that progression easier, as we're going to learn a little bit later today, and reducing some important technical debt to keep the ecosystem sustainable. And I think at this point, we're going to turn it over to our discovery teams to be talking about some of the important work they've been doing.
Awesome. Thank you. My name's Elisa Pierce, and I am the component lead for the discovery platform we call Daylight on our Surfliner team. I'm going to share my screen with you. And what this is going to allow me to do is show you our current progress with our ADRL Lite, otherwise known as Alexandria Digital Research Library. So this is first and Daylight made up of components that basically chunk out pieces of our front end. So this for the allow us to do is quickly bring together pages like this one so that we can yeah, API. And that gave us a facet. So now we have that work through the results of whatever user search that we have. And that gives us the chance to then minimize and filter out content that is wanted by the researcher. So now we have interaction between facets and our result list. Again, components. So we have a component over here for our results list. We have this little component that does our pagination. We get to reuse the component here for our search bar and these facets. And then like the eyebrow gets to be reused throughout multiple pages. And so our MVP was really building out our initial homepage with the search, our search results page to allow a user to more adeptly reduce the results to what they're looking for, and our displaying of our object page here. And so this is essentially our very nicely working search function that also continues to have facets. So this is very exciting for me. We were able to advance the API, like I was saying, and so that gave us over access to consume that API a little bit better and turn it into this human usable interface. And so it's really fun because now we have all these chunks of code that do a lot of the heavy lifting that we'll be able to pull in and use in multiple places. And that's what I have for you today.
All right, I'm just going to catch us up to where we were in the slideshow. Just give me a second. Oh, we already did our live demo. So I'm going to turn it over to other members of the Daylight team who are going to be talking about our progress metrics.
I actually think I'm going to be the one doing this too. So essentially, we identified at the beginning of Daylight basically a shared library of components. We have now completed nearly all of them. There's progress on all of them, but we have some more work to be done on just these last two components. But otherwise, we have a library that is ready to be ingested. And so what that meant is we were able to do some good work in our API. So we have three major endpoints: the facet, search, and object endpoints. This exposes the data and really prepares us for that fully connected Surfliner application. And so up next is our object. We have just a little bit of work there that needs to be done. And then here is what I was talking about earlier. So these are the MVP breakouts of our main pages, our home page, search results page, and object page with a highlighted components there in purple of what is being ingested. So there's a few more little bits, little odds and ends that we have to just really polish out and finish up what's going on. And as more progress is made with those API endpoints, we'll have a little bit of work there that just gets us back in line with what's available. I think there's one more slide.
Yeah, I can take this one. So, just putting all of this together. So we are building out what we've been calling ADRL Lite for UC Santa Barbara, which is also serving as a prototype for the initial discovery implementation for UC San Diego. So in terms of like to have a whole working discovery application, we're actually really close. What we have left mostly on the API side or on the back end is integration with the rest of Surfliner. So being able to pull images out of Surfliner storage, being able to download digital objects, whether those are images or something else, um, and publishing updates from Comet to ADRL Lite, or or the back end of future discovery platform to be named later. We'd also like to be pulling from Lark for the controlled value labels. Right now, we're using kind of a static list of those. And then there are some tweaks to the behavior of the keyword search that we need to do. Those are in progress now. And then we also have a little bit of infrastructure work to do. We have like totally working ADRL Lite stack in development, both for the front end and the back end, and those two things going together. But we're just going to roll out. I think we're maybe got review environments hopefully finished today, and also rolling out QA and production environments so we can get more users. We can get users and not just front and back end developers playing around with this and giving us feedback and identifying improvements. And similarly, what we want those, so like the QA ADRL Lite environment should be pulling data from the QA Comet, and so on and so forth. Oh, Elisa, do you want to talk about Todd's asking which IIIF you were using? Have we made that decision yet? I know you did a feature matrix and some analysis.
I did. So where we've actually done most of our discovery is using the UV, the Universal Viewer, and that one from the landscape review really bubbles up to the top. So I wouldn't be surprised if that was the final one chosen. Mirador, I think, gets eliminated based on its accessibility issues and our upcoming need to be 2.1, WCAG 2.1 AA ready. So we've got stuff started, and we've got stuff implemented, and so we have a plan forward for using a IIIF viewer on our object page. We are just, like David was mentioning, waiting on that image to be able to come over to confirm that everything's working as expected.
Yeah, and we do have a follow-on project, strategic project. I mean, each campus has a follow-on strategic project to develop a next generation discovery system, and I think we'll probably take another look at that question when we are looking at longer timelines, and do we want some of the more elaborate features that we get from some of the other viewers. But Todd, like as you say, like UV is a solid choice. It's what Comet is already using, and it does the things that we currently need to do out of the box. So as we get into identifying requirements for that next generation discovery system, if we find some that suggest that another viewer, whether it's Mirador, assuming we can sort out the accessibility issues, or whether it's Clover, which they're using at Northwestern, if one of those turns out to better fit our needs, then we'll look at that as part of that project. I think that's it.
All right, so now we're going to switch over to updates about our digital object management platform, which you may also know as Comet. And I actually think this is where I'm going to stop sharing my screen. I am up next, and I am going to do the very scary thing of doing a live demo into our shared QA environment. So just to take a quick step back for folks who may not have joined us before, we have a number of environments that are currently running. Each campus has its own respective production and sandbox environments. Production, pretty straightforward. Sandbox is really geared towards library staff to use for their own testing and training and learning purposes. And then we have QA. QA is a shared environment that's primarily used by the development team to test and validate new features, but also just to help support our normal sort of development needs. You'll notice there's a lot of stuff in it right now, and that's because the Daylight and the discovery teams are using this as a source. I think actually this was the source of the data that was going into Elisa's demo. And so what I'm going to do is do a batch ingest of this content. So I I did. I wasn't going to make you all watch like a 20-minute batch ingest. So I timed this out. So it should hopefully take about 3 minutes if all goes well. This is, and just to walk folks through who might not have seen one of these before, this is the structure of a batch ingest template. You can see here, I have this top line is my collection record with metadata that's attached to it. There's this parent column, which is relating the other things here to the appropriate parent. So this next line here is an object record, and this parent column is saying I'm part of this collection. Then we have a couple of lines that are relating up to that object. These are our file sets. And file sets are a PCDM content or concept, PCDM standing for Portland Common Data Model, which is the structural metadata that we use to structure our objects and our collections in Comet. And what a file set is, it's a little bit different than a file. In that it can contain more than one version of the same file. So I'll show you, I'm not going to ingest multiple versions of the files in order to have this go fairly quickly, but I can show you over in the UCSB production instance an example of that. But why you might have multiple versions of a file is you might have a really, really high quality archival file and then a smaller version of the file that's used to create derivatives. A common use case we have here is a negative and then a positive image. So I have already downloaded that file, but I'm here on the Comet dashboard. And we've been really focused on the team on really, I think, the first critical path for both of us, which is getting content in. And so the way we do that is using a tool called bulk racks. And that's this importer stream. So I am going to go and I'm going to create a new importer. And normally I have a structure that I'm using, and this is to track my own ingests. So this is going to possibly be a little bit meaningless to all of you. Here I select a project. In our QA environment, we only have two. But you can have sort of any number of projects that are associated with workflows, and those projects can have specific users that are notified when things happen on those workflows. I'm going to go ahead and upload my file, which you probably can't see the window that popped up. Maybe you can. And I have already, normally I would want to validate this just to make sure everything is working well, but I've already done that. So I'm going to go ahead and click Create an Import. And now you'll see it sort of bumps me back over to my importer screen where I can start to get some metrics on what's happening in terms of, so now it says it's pending and it's given me some information. It knows that it's one collection entry. I have 6 work entries and 12 file set entries. I want to click over. This is not something normally I would, that normal users would do, but I want to sort of talk through what's happening a little bit on the back end. So Sidekick is just our jobs management tool that we're using. And you can see that it is doing a lot of things. There's this bulk import file set job. It's starting to create the relationships. If I click back over here, you'll see I should have started to see some progress in terms of this dashboard. So now I can see that I had 12 entries that are in queued and 7 are processed. And you can see as I refresh over here, I have a whole bunch of really busy jobs. So this is more file sets jobs. I have my characterization jobs that have started and my derivatives. And the thing that I find very interesting about this is at some point, we're going to see over on the Comet side that this is going to say that it's complete. We're very close now. But once that happens, we're going to continue to see that there's a bunch of background stuff that's going to continue to happen for a minute or two afterwards. Once the objects have been fully brought into the system, there's just a huge amount of other tasks that Comet is doing in order to create this object, capture and characterize those files, and to build those relationships out. So I'm going to just keep refreshing. I know it's maybe not that exciting to watch me sit and just refresh a screen. Oh, so here I can see my ingest has finished, but if I go over on my Sidekick side, I'm still seeing a little bit of work that's still happening. I have some relationships that are being finalized. Each one of these is having to say, hey, I'm this object, I'm part of this collection, I have this object, and I have these file sets that are associated with it. And we're getting really, really close. I found it really surprising when I was doing this for larger ingests. You know, a few thousand objects, we'd get up to like 30,000 jobs that were running in the background. So there's really, oh, hey, and now we're all done. So there's a lot that's happening on these ingests.
And just
But no,
so folks know, we do have a ticket in the backlog to figure out which parts of this ordinary users might want to see and make sure those are visible in the main UI. But also, like, a lot of this you don't necessarily need to know, and if you don't know how the backend architecture works, it might seem a little scary. So we're not pointing people toward that.
nope.
The way Bullcracks works is, it's trying to take this large ingest and do it all in parallel and do everything at once across a bunch of different workers. And often that means that it'll be, for instance, it'll want to hook up something like a file to a parent that hasn't been created yet because things are happening just as they happen. And so the way Bullcracks deals with that is it goes, okay, well, I'm just going to kick that job back to the back of the queue. So you will see a lot of these retries and things, but that is all working as expected.
Yeah. One of the reasons why I wanted to talk through this is we were seeing what we thought were issues earlier on in the process, where we realized after the fact, it's just things were still in process. And that's why it wasn't really an error. It was just things were still running in the background. But here is my nice completed ingest. I'm going to just click on a random object and go directly to it. You can see here, this is Universal Viewer. And so I have the nice viewer that is paged. These were just ingested, right? So it's having to generate all of these images for the first time. I can do fun things like rotate it, do a full screen, download it. Also, if I scroll down, you can see here is the metadata that's been pulled in. You'll notice that these are still just links, and that's because we haven't fully connected in with Lark, and the labels are not coming in yet. But we can just see all of our descriptive metadata attached to this object. We can start to see our relationship. So it's in our Vern Todd collection. I can see here all of my my file sets, and if this one had component objects here. And if I click through actually to one of these file sets, you'll see all this detail. So this is all of the characterization results that was happening in the background. So you can see, original checksums, our MIME types, some log information about what I did here. I can also go and just download that original file that I put in from here if I wanted to. I'm going to go back to my object, though. Oops, I went one screen too far back. So here you can see my workflow. And so all of the objects are being put into various workflows. This one's really simple and default, and I can just say, I've reviewed this, everything looks good, and just go ahead and submit for approval, which I did not test yesterday. And I should have done so because this is something we've been doing some adjustments on our workflow, and I think it clearly needs to do some adjustments further. But the one thing, it was successful because you can see it has gone and minted an ARC now, that this object was approved. I do also just want to click I'm not going to select any of these, but this is a nice way to just share. We are connecting Comet to more than one discovery platform. And so this is how, at the individual object level, how I would select to publish to one or more of the discovery platforms. And again, I'm not going to do that, but just to quickly run through them. Daylight, we've already heard from the Daylight team. Shoreline is our geospatial discovery platform. And then Tidewater is our OAI platform. I do just want to jump over really quickly before moving on over into the UCSB production instance, just because I want to show you what it looks like when we have complex objects ingested into the system. So this is one of our air photo flights, and you'll notice there isn't actually an image appearing here because this is a container object. So this object itself doesn't actually contain any images itself. It's just a metadata only object. But here I have a huge number of component objects that have been nested inside of this. And so here are just a bunch of our air photo flights. And you'll scroll down and you can see that I have metadata that's been attached to this flight itself. And then I can see all of my different relationships here. So this is a member of this other object that exists in this collection and in our Air Photos project. So I think that is it in terms of my demo. So I am just going to do a little of screen management here and then turn it back over to David to keep giving us some updates about Comet. So give me a second to manage screens. All right.
Okay, so this is just kind of an overview of where we are with Comet in terms of hitting the MVPs for both campuses. We have some spreadsheets that break this down in a lot more detail, but they're pretty impenetrable if you haven't been in all the meetings where we use them. But just kind of to sum up, we have like these 8 major feature areas from Comet, and as you can see, most of them are completely done at the MVP level for as far as what both campuses are hoping for from the MVP, and we have a couple more couple bits to fill in. Next slide. So in terms of filling in those bits, we have a little bit of work on ordering, especially ordering complex objects and their components in bulk imports. Because bulk racks does everything in parallel, it's kind of puts things in whatever order it processes them, which obviously is not what you want if you're importing scan pages of a book or something like that. So we have our specs for that, and we're probably going to tackle that in this first sprint of the new work cycle. As Chrissy showed, admittedly with test arcs, we are minting arcs when we import objects. But right now, we're not setting metadata to easy ID with those. So we want to send at least the kind of minimum who, what, when, where, why, which would, among other things, let us, that lets us check those arcs against what we have in the system and make sure things match up correctly. Or if we had to do some kind of recovery, it would let us know which arcs go with which source data. And then for UCSB, we're not currently doing DOIs. It's not in our immediate roadmap, but it is an important feature for San Diego. And I think it's still up in the air whether or not that really is an MVP feature for San Diego, or it can be an early post-MVP feature. So we're still figuring that out. We also have some infrastructure work. We've done a lot of work in the last couple of work cycles on kind of the reliability of the whole stack, and our Kubernetes architecture and all of that stuff. We've also done some work now that Chrissy's really been stress testing the system on improving the reliability of the application itself, and especially the bulk import process. And we've been finding small issues here and there and knocking them off. So we're glad to be in a space where we can do more testing and iron out the last few of those. And before we're ready to really take responsibility for people's content, we want to make sure that we'll feel confident accepting that responsibility and saying, yes, it's okay to delete your originals. Yes, it's okay to delete your metadata spreadsheets. And so we have some work to do this sprint to just kind of finalize what our needs are there and make sure we have implementation, and then we have appropriate backup strategies in place and that kind of thing. But we're very close on that as well. So.
I'm muted. So now I'm going to turn it over to Alex, I believe, to talk a little bit about what's been going on with infrastructure resilience and vendor independence.
Hi. So we deploy our applications in Kubernetes, which is an environment used for containerized applications. So if you've used Docker, Docker is this standard way of creating containers, which are self-contained like applications with the full runtime and dependencies. And so it makes it easy to deploy, replace, scale up, scale down, because everything is kind of contained in these units instead of installed directly on a server. For the applications like Comet, Shoreline, we write our own deployment configurations, what are called Helm charts, that basically tell Kubernetes what containers to deploy, how to deploy them, what configurations to inject, how they can talk to each other, all the networking. But for the components like Postgres, Solr, Redis, all the kind of things that we depend on, these are applications that are used by everyone in web development. And so they, for a long time, there were well-maintained Helm charts for these components that everyone used. And they were maintained by a company called Bitnami. Bitnami was bought by VMware. Great, fine, whatever. And then a couple years ago, VMware was bought by Broadcom. Less good, less whatever. And so just this year, Broadcom decided to squeeze some money out of this free resource that was being offered to everyone. So the free offering that Bitnami was providing was kind of a two-part thing. They built their own container images for these applications, and they provided the Helm charts, the kind of the Kubernetes configuration. And because they were trying to ensure kind of standardization across all of these applications, so if you've deployed one thing with these Bitnami charts, it follows all the same kind of conventions as the next one. So it's very easy to kind of use them all. And so for that reason, the containers that Bitnami created and the charts that they created were very kind of closely tied together. You couldn't replace the containers with containers you built yourself or that you got from somewhere else. And so what that means is that now that Broadcom decided we're going to start charging for the containers, the charts are no longer usable either. Technically, they still allow you to use the very latest version containers for free. So like whatever is the latest version of Postgres, whatever is the latest version of Solr, but that's completely unrealistic for a production deployment, because we need to have we need to keep the same version until we're ready to upgrade. Breaking changes happen between major versions, and we can't just use whatever is the latest. So yeah, Michael Stewart was like, hey, how much would it cost for us to pay for their images? What was it, Michael?
A small sum of $60,000 a year.
Yeah, so we
And
decided
that's just for the first year, no promises.
we decided that we, pocket change, we could easily afford it, but we thought we might want to look into alternatives. And so, yeah, so that's thrown a huge wrench in things, because we need to switch how we deploy all of the components that we were using these Bitnami charts for. So some things were relatively easy. We were using a a service called memcached for caching. We realized we didn't actually need caching in where it was being used, so we just dropped it. Redis, we're hopefully going to be able to drop it when we upgrade to the next version of Ruby on Rails. We use Redis for the background jobs queue, the sidekick that Chrissy was demoing uses Redis to kind of queue up all the jobs. When we upgrade to the next version of Ruby on Rails, it has a native jobs queue, and so that doesn't rely on either Sidekick or Redis. So hopefully we can just not worry about replacing that. Postgres, we've begun working on. There is what appears to be a pretty well-maintained third-party and importantly free tool for managing Postgres installations. We're experimenting with that on our less kind of critical services to see how it works, but it seems promising so far. Solar, we're still not sure about. There is not a well-established alternative yet. So we may end up having to write a Helm chart of our own. That's not something we ideally do because it's more maintenance on us to keep it up to date, make sure we don't introduce vulnerabilities, but we'll figure it out. But that has been a huge distraction from actually getting stuff out the door. So if some of us on the ops side have been less responsive than usual, it's because we have been dealing with this minor nightmare. But that's, I think, we're at. Matt Quitchlow, you want to add anything? Michael Stewart?
I think that's great.
Okay.
Yeah, thanks for
I mean,
that.
it's not great, but it is accurate.
Yes.
Thanks for that update, Alex.
Alex, thanks for walking us through that. And I think some of those details are really important because it highlights the complexity of the work that we're trying to take on and write here. But it also, I think, is pointing at what's made the project very sustainable up until this point. And I think I would like to just call out that it would be very easy to try and band-aid a solution with timeline constraints or pressures or desires for us to be almost there. But the team is really thoughtfully thinking about what the right choice is long-term and what that constraint set is. So kudos to the deep thinking and the efforts for getting us over this rather unexpected hump.
Yeah. All right, but I'm going to move us on for updates on what's happening at both campus in terms of our data migration efforts. And I'm going to kick us off by talking about what's been happening at UCSB. So the short story is it's in progress, but there is a caveat to that progress. So far in our production instance, we currently have 25 collections, which are comprised of over 16,000 objects. Many of those are currently metadata-only objects. There's only 285 of them with files. But oh my, look at how many files are in those very, very small number of objects. So we have almost 30,000 files that have been ingested. And the caveat, like as David was talking about earlier, is that we do want to finalize our disaster recovery procedures and process before taking full responsibility for the production content. So you might ask, well, then why are we putting stuff in production? And some of it's, we have a lot to migrate from a bunch of different places. But also, I think importantly, we've been using this as sort of a dual opportunity to do some real production load testing. We've had great testers with feature validation and testing out how things work. But that is really different than, okay, now we're ready to throw hundreds of thousands of objects at the system. And so this work has been real production ingest work, and that has been allowing us to really make some adjustments in a very positive way to the system. We've also been, I've been learning a lot from this. We've been doing a lot of time benchmarking, but we've also been doing it in a way to really minimize the risk. The majority of the content is stuff we are migrating out of ADRL, so we don't have any risk of data loss. We have full objects, we have the arcs, we have everything external to the system. For any new content that I'm putting in, we're just holding off on minting arcs. Which means that we're not at risk of any data loss. The only thing unique in that case would be the arcs. We would potentially be at risk of losing my time doing these objects, but I would argue that this has been a time very well spent since we've been able to really have dual purpose here. At UCSB, for folks who may not be aware, we're actually migrating from multiple sources, many sources. And we have a strategic project team that has developed a migration plan. And it's routing all of our content that needs to go into Comet into different queues based on an inventory and assessment process. And so really, I've been focused on the migration queue, which is the highest priority. So far in that migration queue, we've done 23 metadata for 23, or for all 23 of our image and text collections. The images are in process, the binaries have been extracted, and we're in the process of building out those in some cases, complex file set ingest manifests. For our map and mapsec collections, which had slightly different mapping and modeling, we're currently working on generating those object manifests, and the images will be coming soon. So I want to talk just a little bit about the production load testing, and then I'm going to hand it over to Michael, since Michael Stewart's really been my partner in crime on this. So I've been doing a lot of load testing. And you can see here, oops, I clicked because I wanted to put my cursor on the screen. So one of the groups of content I've been using for production load testing are yearbooks. It's only 86 objects, but it's almost 30,000 files. And so I was able to sort of chunk these out into progressively larger batches and see how well the production system could handle them. I've also just started recently working with our air photos. These are extremely large image files that are ingested in these things called flights. By extremely large, each individual frame has both a almost 500 megabyte preservation negative and a 75 megabyte production positive. We have at UCSB, I think, over 300,000 of these images to ingest, and we have more being created weekly. And as I showed you before, these also represent complex objects. This image I just love because this is Disneyland in 1956, and I discovered this by accident. I've also discovered a talent for just generally stressing the system. I'm really good at mimicking sort of impatient users and just clicking around on things and seeing if I can get the system to fail. And so now I'm going to turn it over to Michael, who can maybe talk about how successful I have been in doing just that.
No, absolutely. If you've ever been in an elevator with someone like it's maybe like, I don't know, has like 100 stories in the building, and someone is pushing all of those buttons at the same time and wondering, I wonder what happens. He has the uncanny ability to unearth reliability and performance issues in our system. So that's a bit of a joke, but also a deep appreciation for what happens when we start poking on things in unexpected ways. So I think the portion I really want to talk about today is how does the strategy for informing big data migration and application performance kind of come together to give us confidence in the actual migrations that we have ahead of us. And so in one of the examples that Chrissy had, we started to ask the question like, so what does happen if we ingest monster loads? And we're like, well, things are not going as expected. In this case, we're talking about large sets of TIFFs from this air photo collection. And while things started off okay, we started seeing like some slowness, and then eventually some sort of tipping point where we were seeing, things generally unreliable and some system crashes. And so our approach was, well, we've been pretty thoughtful in building out the tooling and observability systems to try and help us understand what's going on. So let's go ahead and do that. So with some really structured ways, we're able to see, hey, like, is this because the files are massive and they're getting stuck in derivative processing, or like where exactly is the issue? And I think the insights that we gained is through this method of actually saying, like, where can we find the issue, and how is the type of ingest in files and quantities related to the issues we're seeing? It helped us observe that actually we just needed to scale our infrastructure, which we already had in place. And so a few minor modifications to how many workers and the allocations for those workers resulted in some pretty astounding performance increases. And I think the thing I want to call out here is, as we look at the data ahead, you'll notice the improvements, but ask yourself about, if you are ingesting these, would you appreciate or want to have this type of an increase in your feedback cycle? So please don't think you have to process all this mentally. What I really want to walk you through here is the amount of time at the top and bottom of these columns, and the actual speed up there, and probably noticing that we're going from something like basically 380 files an hour to almost 2,000 files an hour. And we're getting a linear progression with basically as many workers as we had. That's actually really cool. It's very hard to do in some infrastructures. So when you can say, hey, actually just adding another worker gives you basically 1x more performance, that's really impactful for us. So the structure of this table and the next one is actually the exact case that Chrissy was talking about, with those massive preservation files. And you can see in this case, even with that, we're still showing a 4x increase across the board with some relatively minor enhancements to the application configuration on the worker side. That really makes feedback a lot sooner. So going from 32 minutes down to 8 lets you really iterate across those as you're trying to figure out what's going on or do that. So yeah, I think really overall really successful. Kind of proves, I think, our infrastructure patterns are holding up well, especially for larger data migration. And so this is another example that we've sort of recently uncovered, and that we're going to be diving into shortly in the upcoming work cycle. So we have like another what's taking so long, also found by guess who? Chrissy. So thank you, Chrissy. And what it allowed us to do is, actually things are ingesting fine, but when we start clicking around in the application, certain things are taking too long. Again, don't worry about parsing this out. What you're going to notice is, like, you're like, visually that looks like some things are taking much longer than others, and there's a lot of them. What we're highlighting here is our observability platforms in the background kind of hard at work, in this case, Honeycomb. And it's kind of showing us that for something that probably shouldn't take too long or make as many queries to the database, it certainly is doing that. And that lets us bring back those inferences and those findings to our team and say, hey, what do we think about this? Because we think our system selecting metadata seems kind of important. Where else might this be happening? And how else can we sort of make a really concerted effort of investing a small amount of time to address a large amount of performance improvement? And having said that, I think we're going to turn it over to Arwen.
Great, thanks. Chrissy, could I share my screen? Thank you. Okay, so I'm just going to give a super brief update on, or try to make it brief, on what we've been doing as far as data migration at UCSD. There's a couple big primary things we've been focusing on. So the first is doing an analysis of our collections. So we don't have file numbers, unlike Chrissy, but we wanted to look at all the collections we currently have in the dams, and start looking at how we can cluster those collections and break it down so that we can prioritize and order how we're going to approach ingest. So we have currently 500, which is a perfectly round number, 500 collections with about 206,000 objects. The files are going to be kind of like Chrissy showed, an order of magnitude larger, because a lot of those are complex objects. Our general, what we're looking at for actual migration approach is to approach from the simplest and the least risky possible, kind of then building up so that we both build our experience using the tool, and hopefully any bugs that are there we can uncover before we get into the more complex work. So one of the things is starting with restrictions. We don't currently, I think, have restrictions in the end user interface, but these restrictions that are listed here are end user interface restrictions, not Comet restrictions, which is just a backend system. So starting with no restrictions so that we can be completely sure that we're not going to accidentally publish something which we shouldn't be publishing. And then starting with simple objects, which are objects that just have a, they don't have any subcomponents to them, that just have a file attached to the object, or a file set, I should say, attached to the object. When we get into complex, our complex objects are more complex. So we have things like the map sets that Chrissy was describing, where there's a kind of a container object with objects underneath that. We also have things where we've got kind of a complex hierarchical relationship with like groupings of things that then have another layer underneath that. And so this is one of the things where when we're able to start seeing those instantiated in the end user interface, we can really get a better idea of how we need to map those structurally, because the structural representations in Comet are different than in the DAMs. We have file sets and subcomponents in Comet, and we just have subcomponents in the DAMs. Yeah, so there's the other thing this is allowing us to do is identify, it gives us a really, because this is all connected, this is all, let me just, here, hold on a second. Where is this? So this is all coming from a giant spreadsheet that we kind of use generated data from all our collections to get this information. But the cool thing is it means we can narrow down on what kind of thing we want to test. And then we just have a list of the collections that fit that, those parameters. So the other big thing we've been working on is our data migration tool. Since we have so much content and so much to move, I think Longshu might have been the person who came up with this, but it could be, but he did definitely make it. One of our developers, Longshu, created a tool which allows us to choose a collection or an object or a set of objects and export that for staging. So I'm going to try to do a quick demo again, as Chrissy said, fingers crossed. So for example, this is a collection we have in our DAMs. This is a collection of posters from independent film festivals in China. And then we have these objects. Now I chose a small collection. It's only 22 objects for the same reason Chrissy described, trying to keep it brief. So let me just say, I'll probably have to log back in real quick here. So this is the tool. And then briefly just go to, you can put in ARCs, or you can go to the list of collections, select the collection. And then what we have are some options down here. We've got review metadata, which gives us a metadata export. We've got import manually, which is what we've been doing a lot of testing on. So what this does is actually transfers the files into our Comet staging space, which is a different server. And then, and the metadata, and also exports the metadata, which then includes file paths to those specific files. So then up here, it's super fast. One of the things we have tested, and Michael Stewart and Matt Peters have been the kind of driving it with a lot of support from ops folks, is seeing how fast we can transfer things, because we have some collections that are quite large, like tens of thousands of objects. I think terabytes maybe, but definitely a lot of gigabytes. And they've been able to make some changes to that, which have been kind of that same scale that Michael was showing with the other performance factors of making it just kind of exponentially faster. So then what we do with this is we go to, sorry, my Zoom toolbar is covering up my browser toolbar. This is the same thing as the Chrissy did, and I'll just I also pre-validated this just to make sure. Let's see. And so I'm not going to validate, I'm just going to import because of that. Let me, and while we let that go, I'm going to go back to the presentation. So what's happening is it's moving all of these files over into our staging space. It's creating a folder for the collection if you do it by collection, and then within that, all of the individual files that go with that, which are associated with the objects in that collection. It's also doing a conversion of the metadata from the dams into our Comet data model. And that has been something we've been working on a lot, and we have it probably 99% worked out. What it's driven by this, wait, let me see if I clicked on the right thing. It's driven by a style sheet that Longshu created, and he made it so that we could also add updates. So if we find that a note is exporting to the wrong property name, we can update it there. He merges it, and then we can test it. So we've I got another spreadsheet I won't show you with the hundreds of possible property names in our metadata schema that we needed to map. And okay, so I just, let's see if it's done. I'm not even gonna like check the importer. I'm just gonna see if it like is here yet. Yep. So we got our collection, it imported. We've tested this with object collections with thousands of objects, and it seems to be working. What we're still doing testing on the load testing for import, and finding places that where there are issues that need to be addressed for the migration. And I'm going to stop there.
Thanks, Arwen, and apologies. I know it's always tough to be the last person who is talking when we are running long. But I am going to just turn it over to Michael to quickly wrap us up on the current work cycle. I do understand that we are officially at time, so if folks need to drop off, thank you so much for joining us. I hope you can stick around with any questions you have, but if you can't, please do feel free to reach out to us on Slack or email Michael or myself directly, and we're happy to help address those.
Thanks, Chrissy. Really quickly here, this is what fall looks like for us, running through, like we said, September to early December. Again, another 3 sprints ahead. And in the interest of time, we'll just get right into what we're going to be focusing on in terms of themes and goals. So unsurprising, we're going to be working on our discovery platform, our digital object management platform, more application reliability, and some infrastructure resilience. In each of those, we've got sort of thematic ties into really what's going to help us both ingest content and then in a production sense, like remove those last critical path items, and also like how do we sort of support the discovery for that. So really that's the remaining APIs that we have that we heard about, publishing support, resolution for some identifiers in our control vocabulary system, really the infrastructure deployment for our discovery prototypes in both campuses, and sort of finishing off the bulk ingest process for like ordering specifically for components and file sets, validating the disaster recovery plans, which is super important. And again, more critical performance issues that are informed by our data migration testing. And a huge foreshadowing to, I think, to the team that's going to be doing the work migrating away from Bitnami and ensuring our long-term project sustainability.
All right. So I think we are officially at the questions phase. Please do feel free to unmute yourself if you have any, put them in chat. If you're not comfortable asking your questions on video or while we're recording it, we will pause again once we stop the recording. So folks who would feel more comfortable then can ask their questions.
Heather has her hand up.
Oh, hi, all. Hi, I'm Heather from UC San Diego. Wonderful update. Thank you all so much for working obviously so very hard and smartly on all of this. I had a question about the UC Santa Barbara's discovery demo way back at the beginning of this session, specifically the facets that you showed. It looked like in different search result sets, different facets appeared to limit your searches. And I wondered if that was because facets only appear if there is one of those kinds of things available in the search set to limit by, or if different collections or different something or others prompted a different set of facets.
Yeah, no, Heather, your first guess was correct. I mean, there's a few different ways to do facets, and the way we're doing it for this version is basically what the current, or rather, you know, kind of the old Alexandria Digital Research Library did, which is the facets are only there for filtering down your current set of search results. You can't. I mean, you can start with everything and start and filter that. But the intent is just to use the facets as filters, so you don't see all possible facets. You only see the ones that are relevant to your current set of results.
Thanks for clarifying.
That's a great question. Anyone else? All right, so I have counted to 11. I do want to thank everyone again. Thank you so much for joining us. It was great to see so many people here. We'll do a second round of questions in a minute once we stop the recording, but also again, and I will say, please do find us on Slack. We are the most active channel on the UC Tech Slack. So if that is too much for you, we do have a Surfliner announced channel as well, but we are there all the time. We do post this recording and our sprint review recordings on our blog. Please do feel free to reach out to Michael or I directly if you have questions or concerns. And thank you so much, everyone. Gabriella, could you stop the recording?